expand this, and it looks like we're ready to go. Chapter 2, page 60, exercise 2.1. In problems 1 through 8, which of the descriptions define a set? Now you need to look at page 53, because could we go through class today and pick out a set of grouchy people? I mean, could you just look around the room? Well, these two guys on the front row, could they turn around and just look at your faces and identify sets of grouchy people? But here's the question, and see, this is what page 53 says. Would all three people on the front row who made a set of grouchy people by just looking at your faces, would they have the same set? So in math, it's not a set unless everybody can agree on who goes in the set. You follow the thinking? So for problem number 1, would grouchy people define a set? No, because we wouldn't all agree as to who goes in there. Problem 2, good tennis players in the United States. Would we all put the same people? So that's not it's called a well-defined set. And that's what they mean. That's why it's called well-defined sets on page 60. That's what we're looking at here for this first thing. Well-defined means that we have to all agree on what constitutes the set. Problem number 4, students taking mathematics courses at Calvary University at the present moment. All we'd have to do is get the roster for this class. You follow me? And we would all have the same list. So that would be well defined. That would also be true at Yale University, but why should Yale have preference over Calvary University? I just changed the name in there. It wouldn't matter what university it was, it would still be a well-defined set. Number 6, can all of you read that statement for number 6? No. Well, then let's look at it here on the screen. Those little squirrely things, what are those called? Braces? Aren't brackets the squares and those are braces? Is that what you call them in English class, or you have a name for them? Okay, when you see those braces, that's read the set. The set of all elements x such that x is, what do I have out there? LAECN. X is an even counting number. Sometimes when I'm doing designations, I just put the letters for the words. So that's how you read number 6. So not only do you, so somewhere you need to have in your notes that when you look at something like number 6, you go, oh, that's what it's saying. I mean, just look at number 6 in the book now. Don't look at the screen, but look at number 6 and go, oh, that's the set of all the elements x such that bar x is an even counting number. You understand? That's how you read that. That's how you read that notation. So if you've never seen it before, put that in your notes. You're going to need that when it comes test time. So just put that in your notes and say, I need to keep this information so I know how to read this symbolism. Now, the question to ask is, if I have a set of even counting numbers, if we said x is a set where x is an even counting number, okay, what would be the first number you would put in your set?
2.
2. Would all of you put 2 first? Is 2 an even counting number? What's the first counting number? If you start to count people in a room, what do you start with?
1.
1, 2, 3, 4, 5, 6, 7, 8, 9. But even counting numbers would be what? 2, 4, 6, 8, 10. And then if we wanted to keep going, if we wanted you to keep going, we have enough for a pattern, so we'd go dot, dot, dot. But would all of us have the same numbers in our set? Yes? So that makes it well defined. So in problems 1 through 8, is problem number 6 a well-defined set? And the answer to that question is yes. You follow me? In other words, to answer the question for number 6 is just yes or no. But you have to know how to read what number 6 says before you can answer the question. And that's the same with number 7. Well, let's do one of yours, number 7, just for fun, to help you out sort this stuff out. Would someone read number 7 out loud?
X is a good college course.
The set of all x's such that x is a good college course. Would all of you have the same college courses in your set? If not, then the question is, for problems 1 through 8, is number 7 a well-defined set? And the answer would be
No.
no. Everybody follow what's going on here? You can't answer the question until you know how to read the question. Number 8. Would someone like to read number 8? Now that we've had some practice doing this, make you feel powerful. The set of all x elements x such that x is a bad instructor. Would all of you put the same names in the list? No. So it's not well defined. Okay, now let's go to number 10 through 14. Oh no, number 9. Well, it looks like number 9 is yours, so it's like number 10 through 14. In 10 through 14, it says, let X be the set ABXY. So you see how I have it up on the screen there? X is the set ABXY. Maybe I'll put a little red mark in here and just underline it for you. Fill in the blank with one of these two symbols. So for problem number 10, it says A blank X. And I can either put, can you read these two symbols? Do you know how to read these symbols? Do you know what that funny looking little thing is? You know how to read that? Is an element of. So this symbol, it's on page 59, is read is an element of. If this one is an element of, then what's this one?
No.
Is not an element of. So what they're doing here for problems 10 through 14 is they're asking a question. For number 10, is A an element of the set X, or is A not an element of the set X? So look at the set X. What are the elements of the set X?
ABXY.
ABXY. So is A an element of the set? Yes. So for number 10, you put A is an element of X. Number 12, what does number 12 say? Number 12 says X blank X. Okay, now I have two choices. I either put X as an element of X or X is not an element of X. What do you think?
I don't believe so.
It's not an element?
No.
And you say, why not? Because what are the elements of X? A, B, little x, y. That's a capital X, isn't it? Okay, number 14. The set BAY is an element. Okay, so this is not an element. So the set, number 14, the set BAY is an element of X or is not an element of X? Is the word BAY in the set X? No. Oh, the letters are there, but the word BAY isn't there. Picky, picky, picky. You bet it is. Very technical. In other words, if I wanted to say the set BAY is an element of X, guess what I'd have to have in here? I would have to have the word BAY. I'd have a comma after Y and the word BAY written in there. You follow me? But since BAY isn't in there, then this set is not an element, so it's not an element. Okay, so number 15 through 24. What's it say to do? Write a verbal description. So what is number 16? Can you read number 16? Someone read number 16 just for the fun of it. Okay, I will. The set whose elements are the letters M, A, and N. Or you could have said the set consisting of the letters M, A, and N. There's more than one way to say it, but it's basically we're talking about the set whose elements are the letters M, A, and N. And that's what it says. So write a verbal description, number 16. The set whose elements are the letters M, A, and N. So what about number 18? Can anyone read number 18?
Christopher Columbus.
Now, it's Christopher Columbus, but because it's in those braces, it's the set whose element is Christopher Columbus. You follow that? When you see those braces around it, you want to call it the set whose element is Christopher Columbus. So you could say the set consisting of the man named Christopher Columbus, or the set consisting of the man who discovered America. I didn't say he was the first one to discover America. He just discovered America. Part of it anyway. Number 20. How would you read number 20? A verbal description. How did I read number 20? I didn't. I skipped it. The set whose elements are 2, 6, and I just go TWO, SIX, TWELVE, TWENTY, and THIRTY. You see what I'm doing? A verbal description just means you write out the words. For number 20, the set whose elements are TWO, SIX, TWELVE, TWENTY, and THIRTY. Number 22, 3, 6, 9, 12, and then see that dot, 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 clear up to 36. What are we doing? Can you count by twos? 2, 4, 6, 8, 10, 12, dot, dot, dot. Can you count by threes? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. So can you see for 22, you could say the set whose elements are, and you could just write out THREE, S-I-X. You understand? You could just list them all and spell out the word. What did I do for 22? The set of multiples of 3, beginning with 3 and ending with 36. But do you understand that my verbal description might not match the answer key exactly? But if you're saying the same thing, just in a different way, you're still okay. Don't check it wrong when you grade your homework. Okay, what are we doing for 27 through 36? Write the sets using the listing or the roster method. That's not the rooster method, because doesn't rooster have 2 O's in it? It's the roster method. I'm just saying, maybe you've never heard a roster, but you've heard a rooster. So you have to adjust your thinking a little bit and move it over, take the O out, and say, I have a new math word to add to my vocabulary. You go, I hate math. Okay, so have a bucket in your head where you put math words you hate. You don't have to like them to store them away in your head somewhere. Just say, hey, if it says math words on it, I hate them. Okay, so just put math words, parentheses, and I hate them. And it's okay to say that. It kind of gets rid of some of the stress once in a while and helps you move on. And we're supposed to, in problems 27 to 36, write the sets using the listing or the roster method. So, number 28, that's a cool place to start. Can someone read number 28? It's been too long ago. That was 10 minutes ago we did that. It's already evaporated. Okay, let's do it. The set of all elements x such that x is a counting number less than 2. How do you start counting things? You count people in the room by starting with 1, 2, 3, but 28 says counting numbers less than 2. So there it is. I put the cute little braces down there, and then I just put 1 inside. I just listed it, or that's the roster. That's what it means to do when you list it. Number 30, the set of all elements n such that n is a whole number less than 8 1/4. So, whole numbers. Now we know counting numbers, don't we? They start with 1, 2, 3, 4, 5, 6, 7, 8. So if we were doing counting numbers, it would be 1 through 8. But number 30 says whole numbers. So how many people are in this room? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 15, 16, 17, 18, 19, 20. If all of you left, and I'm the only one in here, how many people are in this room? 1. If I leave, how many people are in this room?
19.
What?
19. Well, 0.
0. Yes, 0. If all of us leave, there are 0 in here. So when it comes to whole numbers, you start with 0. And then there can be 1 in the room or 2 in the room, but you could have none in the room. So the difference between counting numbers and whole numbers, maybe think of it as counting numbers are 1, 2, 3, 4. Whole numbers include 0, the big hole in the ground, nothing. So whole numbers are all the counting numbers plus 0. You got that? If you didn't know that, write that down, because you're going to need that information when it comes test time. So my roster has to include 0 because it said whole numbers. So some of this stuff, you say, okay, I can read the notation, I can do what it says, it's just that I don't have it clear in my head the difference between counting numbers and whole numbers. Number 32, the set whose elements are all the numbers such that the number is a counting number between 2 and 7. What's the next counting number after 2? 3, then. So there it is. 3, 4, 5, and 6. You follow what's going on? Number 36. The set of all x's such that x is a counting number greater than 0. So the first counting number, 1, 2, 3, 4. Then see how I go dot, dot, dot? That just means it keeps going. Because there's no end to it, is there? Nope, so you just keep going. All right, let's turn the page and work on number 38. Use this idea to find the set of cars. Use what idea to find the set of cars? Now, I have to go back to page 61. Listed below are the most fuel-efficient cars for this year's model. Use the numbers from 1 to 10 at the beginning of the columns. That's how they've identified the cars. Car 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For example, the set of cars made by Honda is 1, Honda, 2, Honda, not 3, not 4, not 5, not 6, not 7, 8 Honda, 9 Honda. You follow what they're doing? So the set of cars made by Honda is the set whose elements are 1, 2, 8, 9. Now use that idea to find the set of cars, number 38, with automatic transmissions. Turn back to page 61. Automatic transmissions. What would be the cars with automatic transmissions? Look at the transmission column. And what would go in the list? 2, 3, 9, and 10. Everybody follow where we're getting 2, 3, 9, and 10? Good. Number 40. The set of cars that use diesel fuel. Now we go to the fuel column. Where's diesel? What's listed in the set that uses diesel fuel? 4, 5, 6, 7, and 10. Everybody follow that? Well, then you've got that part with. Are you ready for this? We're through with the easy part. Now we're coming to the hard part of the lesson. In problems 44 to 47, state whether sets A and B are equal. And the definition of equal sets is on page 57. And what does page 57 say about equal sets? They have the same elements. Okay, look at problem 44. A is the set of all x's, no, of all n's, of all 2n's plus 1, such that n is a counting number. And B is the set whose elements are 2n minus 1, such that n is a counting number. Do you understand how I just read number 44? Okay, now, the question is, are these sets equal? That's what we're trying to answer. Okay, if n is 1, what's 2n plus 1? Let's just list these up here. If n is 1, what's 2n plus 1?
3.
Thank you. If n is 2, what's 2n plus 1?
1.
What's 2 times 2?
4,
Plus 1?
5,
Okay, we got to get our math straight here, don't we? 5. If n is 3, what's 2 times 3 plus 1? 7. Are we all on the same page here? We're all doing math the same way? If n is 4, what's 2 times 4 plus 1?
9.
So do we have enough of a pattern? 3, 5, 7, 9, dot, dot, dot. So A looks like this. Everybody agree? Can you see that? Is it dark enough, big enough for you to see it? Okay, so now let's come down here and do B. If n is 1, what's 2 times 1 minus 1?
1.
What? 1. If n is 2, what's 2 times 2 minus 1? 3. If n is 3, what's 2 times 3 minus 1?
5.
Whoa, why'd you do that? Nobody asked you to do that. Must have touched something. If n is 4, what's 2 times 4 minus 1?
7.
So B is the set whose elements are 1, 3, 5, 7, dot, dot, dot. Are A and B equal? Do A and B have the identical elements? No. So A does not equal B. And you can't know that until you do all this math. See why I said now we're getting to the hard part of the lesson today. Any questions about this one? Number 46. A is the set 1, 1, 2, 2, 3. And B is the set 1, 2, 3. Does A equal B?
Yes.
Yes or no? It's either yes or no. On the count of 3, just say one or the other. 1, 2, 3. Okay, or say I don't know. 1, 2, 3.
Yes.
There's a whole bunch of people that just aren't willing to commit this morning. Well, look at page 57. For those who said yes, they are equal, you are right. You go, why? Okay, what are the elements of A? 1, 2, and 3. You go 1, 1, 2, 2, 3. If you repeat it, it doesn't mean anything. You could go 1, 1, 1, 1, 1, and it's still just 1, no matter how many times you say it. You go, that is so dumb. Okay, so make a mental note that this part of math is just dumb, and then run with it. Just make a note, say I'm going to do it anyway. So A is really the set 1, 2, 3. And B is the set 1, 2, 3, so that makes them equal. All right, let's look at another one that you're not going to like probably. Number 48. A is the set whose element is 5. B is the set whose element is the letters F-I-V-E. And C, what's it say about C? It doesn't say C, does it? 48? Oh yeah, C is the set whose elements are E, F, V, I. And D, and see, since all the rest of them are listed, I'm going to list D too. And D is the set of the letters in the word repeat. So R-E-P, E-A-T. Why didn't I put E in there twice? Because it's redundant. You understand? The letters in the word repeat are R-E-P, A, and T. It just happens that E is used twice. Now we can answer the questions, can't we? A. 48A. The set containing 5 elements. How many elements in A? 1. How many elements in B? 4. You go, yeah, but it says 5. It's like, no, those are the letters for the word 5. There's only 4 letters there. You go, 5 only has 4 letters in it? That just seems wrong, doesn't it? Oh, don't overthink it. C has 1, 2, 3, 4. And D has 1, 2, 3, 4, 5. There you go. So the answer to 48A is D. The set equal to B. What set is equal to B? B equals what set?
C.
C, because C and B have the same elements in them. They're just in a different order, but order doesn't matter as long as they're the same elements. Maybe you ought to write that one down too and keep it in your notes. This stuff is really picky. Number 48C. What's it say? The set of letters in the word 5. The set of letters in the word 5. What set would that be? B and what? C. Wouldn't it? Wouldn't it be both of them? Okay. Problem 50. Let A equal the set of all x's such that x is a counting number between 4 and 5. What's the next counting number after 4? 5. What's the counting number between 4 and 5? There isn't one. So guess what? A is the set with nothing in it. Any idea how you read that? A is the empty set. There's also another way to write it. A circle with a line through it is the symbol for empty set. But look what are we doing? Problem 50? And B, can you read that? B is empty set. So what we've said so far is A is empty set and B is empty set. So can anyone read C? Be careful. C is the set whose element is the symbol for empty set. See how the guy's getting inside your head and squeezing things? Making it hurt? So, because of what he's done here, that's why I called A the set with nothing in it. Now, with this information, let's see if we can answer the questions. A and B. Are A and B equal or not equal? A is the set with nothing in it, and B is empty set. That makes them equal. Everybody follow that? So what's 50B? A and C. A is the set with nothing in it. C is the set with the symbol for empty set in it. Are they equal? If they were equal, C would be empty, just like A. Since C has something in it, that makes them what? Not equal. Okay? Let's try C. I told you it's going to get harder as we go along here. Let's try C. Here's B, and here's C. What's B? B is the empty set. What's C? C is the set whose element is the symbol for empty set. Are they equal? No, they're not equal either. You got it? And we're the guy who wrote the book. See, if this would have said, if he would have said C is the set, if he would have said C is the set whose element is A, the letter A, that would have been easier for you to sort out in your head, wouldn't it? But he decided to put the symbol for empty set in there just to mess with you. But didn't he do that on the test as well? He put some stuff there just to mess with you. You'll find out after class. If you didn't make 100 on your test, it's laying up here. You can come and pick it up and sit down at these first 2 rows and open your book up, figure out why you missed it. If you can't figure out why you missed it, ask me and I'll sit here and help you work on it. Because we're going to finish up here in a little bit. And then we'll have the rest of the time until you have to go to your next class to correct your test. And then you turn it back in, and then I average the 2 grades together to raise your points on the points for the test in Canvas. Okay, number, what are we? 52. Better hurry if we're going to get done here in time. The universe is the set whose elements are 1, 2, and 3. List all the subsets. Well, first, wouldn't 1, 2, and 3 be a subset? The set itself would be a subset. And then 1 and 2. And watch how you can go through this systematically. And then 1 and 3. And then 2 and 3. See what I'm doing? I take all 3 of them, then I take them 2 at a time. Then I take them 1 at a time. There's 1, there's 2, there's 3, and there's empty set, where there's nothing in there. So, all the subsets are 1, 2, 3, 4, 5, 6, 7, 8. Wow, 8. That's a magic number. You know what that is? That's 2 to the 3rd power equals 8. How many elements in the universe? 1, 2, 3. So that means if I take 2 to the 3rd power, I will get the number of elements. I will get how many subsets I should have. So if you know this rule, if you didn't know it, write it down. And if you know that rule, then you say, hey, if I'm listing them and I don't have 8 of them, then I left one out. And guess which ones are easiest to leave out? The empty set and the set itself. But look what problem 52 in the book does. It says, list all the subsets and then indicate which ones are proper subsets. You know what a proper subset is? It's a subset that stands up straight and doesn't slouch in its chair. No. A proper subset, page 58. A proper subset denoted C, the symbol, that's the symbol for it. A is a proper subset of B. If A is a subset of B, but not equal to B. So, in other words, of all of these subsets here, which subset is equal to the universe? This one. So, mark that one out. Because That one is not proper. So there are 1, 2, 3, 4, 5, 6, 7 proper subsets. So guess what? For proper subsets, you go 2 to the n power, the number of elements in the set, minus 1. Minus that one that's not proper. So the number of proper subsets is 7. Okay? And page 58 makes that clear. Look at page 58 and take what it says and write it in your notes in such a way that it makes sense in your head so you can keep that information available when it comes test time. Number 54. The universe is the set whose element is the empty set symbol. Do you follow that? So what are the subsets? Well, the set itself and then empty set. What are the proper subsets? This is the only proper subset because this is the set itself. So I have one proper subset, and that's empty set. What's another way to say empty set? And see, this is why the book's messing with you. The 0 with the line through it. The O with the line through it. But see, this O with the line through it represents empty set, where this one is a set whose element is the symbol for empty set. See how it's just a little bit different nuance as to how you look at it and read it. 58. How many proper subsets does the set 1, 2, 3, 4 have? Well, see, just for fun, I went ahead and took, I don't know what I'm touching here, but it sure doesn't like it. How many proper subsets? I just actually listed. I listed all of them. But I don't have to list them because it says how many. So if it wants to know how many proper subsets, I just go, how many elements in the set? 1, 2, 3, 4. So I go 2 to the 4th. And then, what did they say for 58? Proper subsets, so I go minus 1. Everybody follow that? So what's 2 times 2?
4.
Times 2?
8.
Times 2.
64.
So 2 to the 4th is 16 minus 1. That's 15. Everybody see what's going on? And sure enough, if you count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See that? But it's always a possibility you overlook one when you're listing them, so just go ahead and write that formula in your notes and remember to use it. 58, number 62. A set has 31 proper subsets. 31 proper subsets. How many elements does it have? Oh, well, that's going to be easy because that's just 2 to the nth power minus 1 equals 31. Right? So I add 1 to both. And I get 2 to the nth power equals 32. So what do I do with 2 to get 32? 2 times 2 is what? 4 times 2?
8.
Times 2?
16.
Times 2?
32.
There's 32. How many times did I multiply 2? 1, 2, 3, 4, 5 times. So n, whoa, there it goes. So n is 5. Which says how many elements does it have? 5 elements. You follow what's going on? Are you feeling powerful? Not yet, huh? Okay, well, let's do another one. 64. A set has 63 proper subsets. Well, then 2 to the n would be 64, and n would be 6. Because if 2 to the 5th is 32, what's 2 to the 6th? 64. 32 times 2 is 64. Okay? You follow the same process of counting through by multiplying. How many times do I multiply 2 to get 64? Number 66. Is empty set a proper subset of empty set? Is empty set a proper subset of empty set? No. No, it isn't. Because empty set equals empty set. Number 70. How many different pizzas with at least one topping could you make? At least one topping. So you could have one topping, that would be 5. You could have 2 toppings, that would be, see that little thing up there? Well, get that off of there. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I made a little tree, that would be 10. 3 toppings would be, whoa, 10 again. 4 toppings would be 5. And 5 toppings would be 1, so it adds up to what? 10, 20, 31. That number looks familiar, doesn't it? 2 to the n, or 2 to the what? 5th is 32. So how come there's just 31 of them? Because you can't have a pizza with no toppings. I mean, you could, but who's going to want it? So, in other words, with proper subsets, we took away the one that was all 5 of them. With this problem, you're taking away the empty set. So knowing that, you could have said, hey, if I have 1, 2, 3, 4, 5 toppings, I'll just take 2 to the n, and that would be 32. Then I'll subtract 1 for the one with no toppings on it that nobody would want. See how that formula is powerful, can do stuff for you? Number 72. If Gino's Pizza says we're going to top Wendy's claim and advertise that we have 500 different pizzas, okay, 2 times 2 times 2 times 2 times 2 till I get a number that's greater than 500. Let's just do that, just for fun. 2 times 2 is what?
4.
Times 2
8.
times 2
16.
times 2
32.
times 2
64.
times 2
128.
times 2
156. 256.
256 times 2 512. And how many times did I multiply 2? 9 times. So all they have to have is 9 different toppings to say they have over 500 different kinds of pizzas they can make. Stop when you get to 71. That's the end of your homework. So now I'm going to turn off the video and sit down here and answer questions.